Hi, I'm Kestutis, and in this video, I'm going to tell you what is NVMe. NVMe stands for Non-Volatile Memory Express. It's a storage interface and a transfer protocol for solid-state drives, also known as SSDs. Currently, NVMe has the fastest response time for computers that use the Peripheral Component Interconnect Express Bus, or more commonly, PCIe. To understand how NVMe works, let's talk about storage systems. Mechanical hard disk drives, or HDDs, were widely used in computers to store data. A hard drive consists of a dynamic spinning platter or multiple platters that read and write data in binary code, with a capacity to store over 1 trillion bits per platter. That's a lot of bits. But with the emergence of flash storage, HDD is becoming outdated. Flash memory uses chips to write and store data, so there are no moving parts. But unlike your computer's RAM storage, it doesn't require power to retain data. Memory cards and USB sticks are the perfect usage example of flash storage. Storing data inside flash memory chips results in fast performance when booting your system up, launching apps, and transferring data. Because of that, SSDs are much more popular than HDDs. For everything to work, the flash chip memory needs an interface and a transfer protocol to connect with the system. That's where the Serial Advancement Technology Attachment, or SATA, driver comes in. It connects storage systems with computers through host controllers, like the Advanced Host Controller Interface, or AHCI. SATA is used in numerous devices, such as laptops, desktop computers, and servers. It also simplified the process of switching from HDD to SSD-based storage in computing environments. However, SATA suffers from some bottlenecks and is considered slow when processing large data projects. Moreover, each SATA drive needs its own port in the motherboard, so there is a limit to the number of storage systems you can connect to the device. The PCIe becomes the following storage interface to tackle those downsides, thanks to its interface speed and proximity to the CPU. PCIe slots connect directly to the CPU and can run a very efficient software stack. Combined with NVMe, it makes reading and writing large amounts of data much faster. Let's dive deeper into how NVMe compares to SATA SSDs. Starting with the data transfer speed, NVMe allows SSDs to connect directly to the CPU via the PCIe bus to transfer data via high-speed lanes. A single Gen 4 PCIe lane can transfer up to 2,000 megabytes per second, with NVMe SSDs using up to 4 lanes. In comparison, SATA only has 1 lane, which can only transfer up to 600 megabytes per second. Next is performance optimization. The SATA interface uses AHCI drivers, while NVMe is explicitly designed for SSDs using flash storage technology. It is not only faster but also offers optimized performance. SATA communicates with the SATA controller before connecting to the system's CPU, while the NVMe standard connects the SSD to the CPU directly. One way that NVMe achieves this optimization is in the reduction of CPU cycles. Using the NVMe technology, the CPU manages queues more efficiently, in comparison with the SATA SSDs that produce high CPU cycles in the input-output or simply I/O processing. What this means is that NVMe can transfer more files without stressing your CPU as much. NVMe also offers lower latency rates. That's because of the shortened and optimized data path. But how about usage compatibility? The NVMe SSDs are best for handling enterprise workload, artificial intelligence, machine learning projects, real-time analytics, and development operations. They are commonly used in data centers and high-end computers. Meanwhile, SATA SSDs are best for small data analytics and light storage applications. They are primarily used in budget computers and servers. Finally, let's talk about the price. As you may have imagined, the NVMe SSDs are more expensive than their SATA counterparts. The current price of a terabyte of SATA SSD storage is around $100. In comparison, the NVMe SSDs cost around $130 to $200 per terabyte. The NVMe SSD is available in several form factors, such as the PCIe card slot, M.2, and U.2. Note that there are SATA SSDs that use the PCIe or the M.2 slot, but still use AHCI and not NVMe. However, U.2 is a form factor that exclusively uses the NVMe protocol. Then also check if your motherboard supports NVMe SSDs. Also note that some motherboards that support it may not always refer to it as NVMe, but PCIe mode instead. So, pay close attention to these factors and do your research to find out if your system supports NVMe. Other than the hardware compatibility, not all operating systems support NVMe SSDs. Fortunately, the latest versions of Linux, Windows, Chrome OS, and Mac OS all support NVMe. And that's it! You've learned what NVMe is and how it differs from other protocols. Are you planning to switch from your SATA SSD to NVMe? Share your thoughts in the comments. If you like this video, don't forget to give it a thumbs up and share it with someone who could use some faster storage. Subscribe to the Hostinger Academy YouTube channel for more videos about website development and tech-related content. Best of luck in your online journey!